So it's a little bit overwhelming, just covering that short period of time. So I want to give some background and kind of go back in time and talk about how we got here, and also just give some of the basic science and understanding for anyone who doesn't have it. So I am keeping it light on images tonight because I just don't want to overwhelm everyone with lots of different things. So I'm just going to continue to return to this sort of as the background for the entire talk. This first image that we looked at the tar sands. So the first thing that I want to talk about is I want to mention three scientists from the very earliest stages of global warming who helped to figure out the basics, just to help everyone understand how far back our understanding of this goes. So in 1824, Joseph Fourier is one of the first people to describe the greenhouse effect, which is just the way that the Earth is actually kept warm enough to sustain life. Basically, gases in the atmosphere that we call greenhouse gases, like carbon dioxide or methane, they trap heat from the sun's rays, and that's basically what makes the planet what it is. That's what makes it habitable. In 1861, John Tyndall suggested that altering the amount of those gases might be able to change the climate, writing, quote, "A slight change in the atmosphere's various constituents might be enough to produce all the mutations of climate which the research of geologists reveal." Jumping forward to 1938, G.S. Callender is the first who really lays out the theory of man-made global warming in its current form. He suggests that all the CO2 and other greenhouse gases industry has been adding to the atmosphere is throwing off a natural balance and trapping more heat. This is what global warming is. So none of these three scientists, just to clarify, were necessarily that concerned or thought that a lot of danger or harm could come from the planet, because at the time it was just so unthinkable that we had that kind of power to affect a system as large as the climate. So jumping forward, in 1957, an oceanographer studying the climate named Roger Revel frames it extremely clearly in a way that for the first time really captures the public's attention. He says, "Human beings are now carrying out a large-scale geophysical experiment of a kind that could not have happened in the past nor be reproduced in the future. Within a few centuries, we are returning to the atmosphere and oceans the concentrated organic carbon stored in sedimentary rocks over hundreds of millions of years." It's worth mentioning here that Revel had previously done research for the US Navy, overseeing nuclear testings in the Bikini Islands. At this point, the Cold War is on, and nuclear bombs have given people more of a sense that we could have a significant impact on the atmosphere. Other scientists around this time begin looking at weather control as a potential Cold War weapon. Interest in weaponizing climate science and also fear of the Soviets doing it first is part of what secured government funding for climate scientists in the first place. In 1965, Revel hires a younger scientist named Charles Keeling to start monitoring CO2 emissions at Mauna Loa, Hawaii, to test his theory. The result is the Keeling curve. This graph behind me representing the rise in CO2 emissions is still basically the standard visual for explaining what global warming is. It's just the parts per million of carbon dioxide plotted over time in our atmosphere. Some people have suggested that in the future, we're going to look back and trace events by this graph, that we're going to look back at major events in history and plot them by what the parts per million CO2 count was because of the effects of global warming in the future. So maybe think about that while I go through the rest of these examples on the timeline. This same year, still 1965, Revel and Keeling also write a report for President Johnson about global warming with his Science Advisory Committee. It explains that all animals, including humans, procure the substance of their bodies and the energy from living the substance of their bodies and the energy for living from the carbon compounds made by plants. And let me just go back to the slide.
Nathan?
Yeah.
Read that whole thing one more time.
Sure. So this is Revel and Keeling are working together to write a report for President Johnson about global warming with his Science Advisory Committee. And just a detail that is explained in that report, is that all animals, including humans, procure the substance of their bodies and the energy for living from the carbon compounds that are made by plants, and that all fuels used by man consist of carbon compounds produced by ancient or modern plants. And then they repeated Rebel's warning that within a few short centuries, we are returning to the air a significant part of the carbon that is slowly extracted by plants and buried in the sediments during 500 million years. So, as I wrote about in the last article in the Worker that some of you have probably read, during the 1970s, some of the best research on global warming was done by scientists at Exxon. And because that article is available, I'm not going to go into too much detail here. I'm just going to give one piece of information from 1978. And that's when Exxon scientist James Black wrote to Exxon executives, quote, "Present thinking holds that man has a time window of 5 to 10 years before the need for hard decisions regarding changes in energy strategies might become critical." And Exxon responded to these revelations by fortifying infrastructure, like this tallest freestanding concrete structure in the world, which is an oil well that is still standing today that Exxon uses. This was built after these revelations. And funding misinformation campaigns in the coming decades. I might leave this picture up for a while. In 1979, President Carter asked the National Academy of Sciences for a report on global warming, and they present him with, quote, "a consensus on warming." It reads, "We now have incontrovertible evidence that the atmosphere is indeed changing, and that we ourselves contribute to that change." It presents several mathematical models for how this warming could play out and says, "It is significant that none of the model calculations predicts negligible warming." And it concludes, "A wait and see policy might mean waiting until it's too late." This is something that you hear over and over again when you look back at these documents. In 1983, the National Academy of Sciences gives another report, but this time under President Reagan, and with the input from 2 economists. They decide that the science is sound, but that there's not much we can do but cautiously watch it unfold. The same year, the EPA counters with a report of its own, obviously a response to the first report, calling for urgent action, but also struggling to come up with politically feasible suggestions. Later that year, the New York Times runs an article misrepresenting the differing reports from government agencies as a debate over the science, which it was not. In 1988, a lot of you probably remember that James Hansen, a NASA scientist, who actually wrote his PhD on the greenhouse effect on Venus's atmosphere and how it makes it basically a planet that's not habitable to life. He gave a speech to the Senate that maybe more than any others that I'm mentioning tonight raised the profile of global warming in the public sphere. Following 2 of the warmest years ever recorded, he announces that the greenhouse effect is here. Later that same year, the Intergovernmental Panel on Climate Change, the IPCC, is founded in hopes that it can inform UN treaties on climate change. Specifically for the United Nations Framework Convention on Climate Change by implementing protocols like the Kyoto Treaty and other treaties you've probably heard of by those names. And in the presidential election that year, the candidate George H.W. Bush promises to combat the greenhouse effect with, quote, the White House effect. In 1990, the year of the first IPCC report and also the year that I was born, let me just pause here and actually ask you a question. So, the imbalance in CO2 has steadily been rising since the Industrial Revolution. And given everything we just went over, knowing what the public understanding of the situation was at this exact point, how much of the total man-made CO2 emissions that are in the air right now do you think have been emitted just since 1990? Anybody want to take a guess?
Sure. 50%.
Yeah, exactly 50%. Good guess. But continue to be shocked by that figure. 50% of all of the emissions that we are responsible for that are in the atmosphere have been emitted just since the year 1990, when we had this level of understanding. If we go back to about 75 years, that number is closer to 90%. So this first IPCC report gives basic facts that we're all dealing with today. They're all pretty much accurate except for one thing, and that's that the predictions have all come true sooner than we expected. So let's just pause here on the timeline for a second to understand why that is.